Welcome everyone to Algebra 2, Section 7.1. In Chapter 7, we're going to be talking about exponential, radical, and logarithmic functions. Now, I want to note that first, we're going to just talk about exponential and radical functions, and we're going to do that in Sections 1 through 4. Then we're going to take a test. And it'll be different than our other mid-unit tests we've taken this year. They're just going to be its own separate test. Then we're going to do Sections 5, 6, and 7 over logarithms. And we're going to take a separate test just over those 3 sections. So there will not be a test over all 7 sections. There'll be a test over the first 4 and then a test over the last 3. So section 1, radical expressions and rational exponents. Radical expressions and rational exponents. So warm up. A, what is the value of negative 6 times the square root of 49 minus 2 cubed? So the square root of 49 is 7, so you have negative 6 times 7. 2 cubed is 8. So 6 times 7 is 42 minus 8. That is going to be negative 50. Oops, excuse me, I messed up. There should be a negative 42, which is how you get negative 50. Then on letter B, what's the value of 1/4 to the negative second? Negative exponents, we must recall, tell us to reciprocate it. So it's really the same thing as 4 over 1 to the second power. Then from there, we square that, and we say, okay, you have 4 squared over 1 squared, because you have the exponent on the top and bottom. You multiply the exponents with the exponents. 1 times 1, or 1 times 2 is 2, and 1 times 2 is 2. Then we say, well, 4 squared is 16, 1 is 1, so you just get 16. All right. Now, evaluate these. X squared, when x equals 3, well, it's 9. When x equals negative 3, well, it's still 9 because a negative times a negative is still a positive. Whereas x cubed, 2 times 2 times 2 is 8. And if you do a negative 2 3 different times, we will have positive 4 times a negative 2, which will then give us negative 8. So there is a difference there for when we cube versus square negatives. Now we're going to talk about a lot of radicals and different exponents on the variables and how they can interact with each other. So we're going to have something that we're going to call the nth root, nth, instead of like 5th, 4th, 10th, whatever, it's going to be nth. And so we're going to have the nth root of a, so instead of like the square root, third root, fourth, square root is our typical one, we'll have some number n there, where n is called the index number, so the index number of the radical. So we could take the cube root, for example, so it could look like that, the cube root of a. For example, the cube root of 8 is 2, because 2 times 2 times 2, or 2 cubed, is 8. Now, if n is an even integer, such as 2, 4, 6, 8, so on and so forth, and a is less than 0, so a negative number, you get 2 non-real solutions, aka imaginary solutions. So that's like saying you're taking the square root of a negative, or the 4th root of a negative, or so on and so forth. Now, if you're taking the even root of 0, so square root of 0, 4th root of 0, you'll get 1 real solution as your answer. And if a is greater than 0, it's a positive, you're going to get 2 real solutions. Some examples of each of those. The first one would be like the 4th root of negative 16 is going to be positive or negative, because you're going to take positive and negative factors, 2i, because 2 to the 4th is 16, but you have the 4th root of negative 1, which is I. So one real solution would be like the 6th root, another even root of 0. Well, 0 to the 6th power is 0. And then a positive would be like the 4th root of 16, and you get positive or negative 2. Now, if we have an odd integer, so we're taking like the 3rd root, the 5th root, so on and so forth, and it's a negative, you're going to get 1 real solution. So that was like our x cubed. When it was negative 2, we got negative 8. So if you did the reverse of that, the example could be like the cube root of -8, or the third root of -8, either way. And you get -2 as your answer. And if a is equal to 0, well, you also have one real solution. So like the third root of 0 is 0, because 0 times 0 times 0. And if a is a positive greater than 0, there's also one real solution regardless. Because you'd say you could have the cube root of 8, well, that'd just be 2, because 2 times 2 times 2 is 8. So we're also going to learn how to rewrite these. So we can express exponents as fractions, okay? We call it exponential notation when we take radicals and we turn them into exponents. So for example, the square root of a can be read as a to the first to the second root, or the second root or the square root of a to the first. And so we write it as a to the 1/2, or 1 over 2. And how we arrive at that is the exponent on the a itself is on the top of the fraction, whereas the index number, the type of root we have, second root, fourth root, third root, fourth root, is on the bottom of the fraction. So using that, we say a to the third root of a to the first is a to the 1/3. Once again, that 1 is on the top and that 3 is on the bottom. So go ahead and see if you can figure out what the next one's going to be. It'll be a to the 3/4. Now, taking exponential notation and going back to radical notation, we'd say, okay, a to the 5th, because that's the top number, and we're taking the third root of that, because that's the bottom number. Go and try the next one on your own. Excuse me, that's the one's a little tricky, I should say, because it has a negative with it. So the negative, like I said earlier, tells us to reciprocate it. So flip it upside down. So it technically has a 1 under it right now. So we have to put it 1 over. So it's going to be 1 over just an a, or a to the first, and it'll be the 6th root of that. And once again, because it was a negative, we had to put 1 over it rather than just the 6th root of a. So using that, we can try and figure out the next one. The next one is 1 over the cube root of a squared. So it'll be a, and it'll have a negative exponent because it was put on the bottom, so we'll want to reciprocate it back to put it on the top. And then it was squared and the third root, so 2 over 3. So we can try these examples now. And I want you to try A through D here on example 3. So letter A, 12 to the first, and the cube root of it, so it's 12 to the 1/3. 8 to the 1/5. This one's written a little bit differently. So it's still being raised to the 7th power, and we're taking the third root, even if it's not inside the radical. So we're going to take 10 to the 7/3. So 7 will still be on the top there. So on letter D, 15 to the 3/8. Now try and go back the other direction in number 4, or example 4. So example 4, the 4th root of 5, or 5 to the 1st. The cube root of 7. The 5th root of 14 squared. And the 4th root of 21 to the 9th. Moving on. So trying to figure these out without a calculator. The 6th root of 64, so you say, okay, what times itself 6 times would be 64? Well, it's probably going to have to be a really small number because as we take a number times itself so many times, it gets really big really fast. So 2 to the 6th power, and you could end up figuring it out by doing 2 times 2 times 2 times 2 times 2 times 2, and actually evaluating that, and you would get 64. So 2 is the 6th root. Now on this one, the negative 32 to the negative 3/5. it might be easier to write this as a radical first. So negative exponent tells us to put it on the bottom. So then we have 32 cubed, and we're taking the fifth root of it. Now it says, hey, always find the root first. So it's a good idea to make the number smaller by finding the root of it, the fifth root of 32, before making it bigger by cubing it. So if we do that, the fifth root of 32, because we can do these in either order, I should say, the fifth root of 32 is 2. So now we end up with 1 over 2 cubed. That becomes a lot nicer than what we started with, where it's 1 over 8. You can still get there by cubing 32 and then taking the fifth root, but you just make your numbers a lot bigger. 16 to the 3 halves, once again, can be helpful to rewrite it as a radical. So 16 cubed, but we're taking the square root, which you can write a 2 there, but we don't have to. So the square root of 16 is 4. So now we have 4 cubed, and that would be 64. Last but not least, I want you to try this one on your own. The cube root of 64 is negative 4, and if we take that to the 4th power, keep in mind we have to do the negative as part of that, so you'll get an even number of negatives, thus making it a positive. So 4 to the 4th power, or negative 4 to the 4th power, is 256. Next, try approximating these with a calculator. So on the calculator, just like we had before, take 22, hit that caret button right above the division sign, and then in there you can type in that fraction, 1 divided by 4. And if you do, and let's just round to the nearest hundredth, which is 2 decimal places, you get approximately 2.17. Now, when they're written as a radical, they're going to be easier to type in to your calculator when you type them in as exponents. So if we call it 11 to the 4/5, you can then type that in. And that would be approximately 6.81. Go ahead and try the next couple on your own. C ends up being approximately 0.10, because it would end up being 0.095, which rounds to 0.10. And you can type in the negative just fine on your calculator too in the exponents. D will rewrite as negative 28 to the 1/3. And after you do that and type it in your calculator, you get it to be approximately negative 3.04. E is rewritten as negative 26 to the 1/4. And the answer to that would be approximately, just kidding, you can't take an even root of a negative number. And your calculator will say that it can't happen. And so you say, well, it does not exist, or it's imaginary, non-real, whatever you want to say. You would say something along these lines. Because once again, it's an even root of a negative number. Now, in order to solve equations with these kind of exponents and roots, in order to do that, we need to isolate the quantity raised to a power. So whatever is raised to a power, we get it by itself, just like when something was being squared, we did the same thing. We isolate it. Then we take, instead of the square root necessarily, we take the nth root of both sides. And I want to emphasize both sides. You have to do it to both sides all the time. It's just like when we add to one side, we have to add to the other. And if the power is odd, you'll get one solution. If it's an even power, you'll usually get 2 solutions. And we talked about those scenarios when you wouldn't earlier, where you have n is an even integer. We talked about, hey, sometimes you get 1 real solution, the 2 non-real, the 2 real. So on letter A, we say, okay, what's being raised to a power? Well, 5's not being raised to a power, but x is. So let's get x cubed by itself. So we divide by 5. And we get x cubed is equal to 216. Now to undo the power of 3, just like we undid the power of 2 by square rooting, we undo the power of 3 by cube rooting, and we do it to both sides. So we get x equals, the cube root of 216 is 6. And because it's an odd power or an odd exponent, and thus an odd root, we get one answer, and it's just the positive 6, because positive 6 times positive 6 times positive 6 is a positive 216. Once again, isolated whatever's being taken to a power or exponent, then we take the root. Letter B, the x is being raised to the 6th power, so subtract the 36. So we get x to the 6 is equal to 64. So to undo the power of 6, we take the 6th root. You just pick that same number, and we get x equals, and because it's an even root, we have both positive and negative, 2. Now I should also note that in order to find those nth roots on your calculator, you can do that. You'll have to go into the math button, and in the math button, you'll notice there's a button that says on mine and calculating for the app, it's option 5 where it says nth, and it has that little root symbol, and it says calculates the nth root. On the TA84s we use in class, it will have a little x as the index number, and so you'll use that one. And so you have to hit X root, or that button, and you have to type in there the number you want. So if you wanted to take, for example, the 6th root of 64, you would type that in there, and it says, yeah, it's 2. Moving on to example C. This time, x plus 10 is being raised to the 5th power, so we'll divide by 2 and get x plus 10 to the 5th power is equal to 70. Now we undo the 5th root, or the exponent of 5 by taking the 5th root. X plus 10 is approximately, because it's not exactly anything, nothing times itself 5 times is 70. So the 5th root is approximately 2 decimals, 2.34. And because it's an odd root, we only have one answer, not 2, not a positive, negative. Now we subtract 10 to get x by itself, and we get x is approximately negative 7.66. So what was different on this one compared to the other ones? Well, 2 things. First, it wasn't just the variable x being raised to a power, it was x plus 10. Second, the other thing that was different was we didn't have a perfect root like we did on the first 2. So because of that, we rounded. Example D, we have a little bit more going on here. So here, we have a negative exponent on the top. So whenever there's a negative exponent, we need to flip that. So the negative 12 won't move though, because it has an exponent of a positive 1. So that's fine. So you have a 1 on the top, a negative 12 on the bottom still, but x cubed moves to the bottom and becomes a positive exponent. And on the right side, nothing changes because there's no negative exponents. Now in order to solve this when there's 2 fractions like this equal to each other, we cross multiply. And you may not remember this, or you may remember it from geometry, where you multiply diagonally. So we take 1 times 1500, which is 1500. And we take negative 12x cubed times negative 1, and we get positive 12x cubed. Now, in order to isolate what's being taken to a power, we divide by 12. And we get 125 is equal to x cubed. Undo the power of 3, we take the cube root. Odd exponent, 1 power, or 1 answer, so we get x equals 5. And just like any problem, we can check our work by plugging these in. Next, we're going to do example E. Suggest you try this one on your own. Start by subtracting 5, so you get negative x to the 4th is equal to negative 625. Divide by a negative 1, or multiply by negative 1. X to the 4th is 625. To undo the power of 4, we take the 4th root of both sides. X is equal to an even power, even root, so positive and negative, and it'll be 5. Suggest you also try example F on your own. F will divide by 4, x plus 3 squared is equal to 49. Take the square root to undo this exponent of 2. X plus 3 is equal to positive or negative 7 because it's an even root. Not quite done, so we're going to split it up into two equations. X plus 3 equals 7. X plus 3 equals negative 7. Solve both by subtracting 3, and we get x equals 4, and x equals negative 10. And I typically put them least greatest, but it doesn't super matter. So once again, on those 6 examples, we need to isolate whatever's being raised to the power, then take the nth root, and then sometimes, like we saw in examples C and F, you have to keep going because x is not quite by itself, or the variable is not quite by itself. Let's move to example 8. The shot used in men's shot put, so that's a thing that they throw, has a volume of about 905 cubic centimeters. Find the radius of the shot. It says, hey, hint, volume of a sphere, which a shot is a sphere, 4/3 pi r cubed. And it says, hey, don't round to the very last step, just to avoid extra errors. So we know the volume is 905 cubic centimeters, so 905 equals 4/3 pi r cubed. So, good idea to divide by pi, and you get 905 pi is equal to 4/3. Sorry, I should have clarified. Our goal is still the same, get r by itself. So, it's being raised to a power, we need to isolate it, then we'll need a cube root. So now multiply by not 4/3, but 3/4. And those reduce on the right, on the left. No reducing happens, unfortunately, as much as you would love there to be some reducing. And you have 3 times 905, which is 2,715 over 4 pi is equal to r cubed. Then we take the cube root of both sides, and you can type all of this into your calculator. You just have to be careful that you put what's inside the radical in parentheses, so that way you can make sure that you get your division done properly, or at least the denominator in parentheses. So if you do that, and let's round to the nearest whole number, you get r to be approximately 6 centimeters. All right, now I'll do example 9. Area of a circle is 400 square meters. Where is the diameter, or excuse me, what is the diameter of the circle rounded to the nearest tenths place? And hint, the area of a circle is area equals pi r squared, where r is the radius. Notice radius is in all caps. Take a second and think, well, why would that be in all caps? It's because that the formula that we're going to use will give us the radius, but we're being asked for the diameter. We have to remember, how do we go from radius to diameter? And the diameter is twice the length of the radius, so we'll have to double the answer when we get it in order to get the diameter. All right, so we plug 400 in, and it's set it equal to pi r squared. And just like we have been, we start solving for the variable. So r squared is being multiplied by pi, so we divide by pi. So you have 400 divided by pi, which, yeah, you could make a decimal, but it might throw the rounding off, so I wouldn't yet. And that'll equal r squared. Now to undo the square, you square root both sides, and we end up getting, after we type that all in your calculator, approximately 11.3 inches. And you might say, or excuse me, not inches, but meters. You might say, well, Mr. Kossel, when we square root both sides of an equation, we should get a positive and negative. And maybe you aren't saying that, but you're like, oh yeah, I'm definitely saying that, you know. Anyway, the reason why you don't have to worry about the negative scenario is you can't have a negative length or a negative measurement at all. So now we got the radius to be 11.3 meters. And so we said, okay, in order to know the diameter, we said we'd have to double it to get 22.6 approximately as a number of meters. So that's our answer for number 9. Number 10. I want you to try this one on your own. It's very similar to number 8, just with a different number. Rather than 905, it's 821. Okay, so 821 is equal to 4/3 pi r cubed. So in order to get, in order to get r cubed by itself, we have to get rid of pi and 4/3. So I'm going to divide by pi, and then get 821 over pi is equal to 4/3 r cubed. Don't need the 4/3, let's multiply by 3/4. On the left, we end up getting 2,463 over 4 pi. On the right, you just are left with r cubed. Now, real quick, I do want to mention that you could actually do those first 2 steps in reverse. You could multiply by 4/3 first, or excuse me, 3/4 first, and then divide by pi, and you get the same thing. Or you can even do them in the same exact step if you want. So, if you wanted to, you could do this. Start with the 821 is equal to 4/3 pi r cubed. And then for your first step, you can multiply the right side by 3 over 4 pi. Because as you notice, pi is technically on top of the fraction 2, and so is r cubed. So what's going to happen is that you have 4 being reduced, pi being reduced, and 3 being reduced. So you still accomplish the same goal on the right side of just getting r cubed. And on the left side, if you do that, you have the same scenario over 1, and nothing reduces, so you just multiply straight across and get the same 2,400, let me rewrite that, 2,463 over 4 pi. So we end up at the same spot in one less step. So if that's something you would like to do, definitely know it's an option there. Otherwise, you can do the same thing we did on the left, and that's fine. Anyway, focusing back on this, let's go ahead and get the r by itself by cube rooting, or the third root, you could also say. Typing that all in our calculator, thankfully it can handle that, we get r to be approximately 5.8 inches. And I didn't say where to round, so I'm just going to say nearest tenth like we did on the last one. All right, that is section 7.1.